I mentioned in class this morning that I wanted to make sure to give you a little bit more instruction on that chapter 12, problem 56 that I gave you at the end of class on Friday. So I'll walk you through this and make sure that you're comfortable with the units. This is a lot like the units that we worked with in class on Monday when we were moving from percent by mass to any other unit like molality. So what this question is asking has to do with basically if we have a percent by mass, then how much of that chemical is present in a given volume of water. And the key is to use the density. And so this problem actually says, go ahead and use a density of 1 gram per milliliter. Anytime you're given a percent by mass, think of it as an amount out of 100. This is analogous to a test score or any other percentage that you're familiar with. So when you see a number given as a percent by mass, then take that same number, call it the mass of the chemical, and then put in the denominator the mass of the solution. Remember, solution mass, a solution is made up of solute and solvent. So anytime you need to move into the solvent only, like in molality, then you need to subtract the mass of the solute from the mass of the solution. At any rate, here's what we've got for an expression for percent by mass. I have at the bottom listed the final unit that we want to get to, which is grams of dioxin. If we start a dimensional analysis problem with 0.085 grams of dioxin over 100 grams of solution, then one of the first things we can cancel out has to do with the grams of solution and try to get it to volume. I'm getting it to volume because of this 2.5 right here. See this? This is in liters. So I want to be able to get to liters so I can use this number somehow. Down here in the dimensional analysis, I'm using the density. 1 gram of solution is the same as 1 milliliter of solution. So now I'm in grams per milliliter and I can move over to liters. If you have any trouble converting units between milli and kind of regular units like milliliters to liters, go ahead and include it in your dimensional analysis. Then you won't forget whether or not you're multiplying or dividing. The last thing we want to do is cancel out liters, because so far we've canceled out grams of solution with grams of solution, milliliters of solution with milliliters of solution. So I want to know if there's 0.085 grams of dioxin per 100 grams, how many are in 2.5 liters. Calculate this out, see what you get. Let's see if we match 2.1 grams. We can go a lot of different directions with percent by mass, and we worked on it in class on Monday, and this is just another example of how to work with it if you're trying to find a mass in a given volume. Hope this helps with your concentration units. Have a great day.